AC Milwaukee operations in Oak Creek, Wisconsin, where AC Spark Plug Division of General Motors manufactures the catalytic converter.
Since most governments started imposing stronger emissions laws in 1970 in an attempt to minimize air pollution, several automakers have been required to examine their engine and exhaust system designs rapidly. As a result, laws like the U.S. Clean Air Act of 1970 were passed, requiring factories to cut harmful emissions such as nitrogen oxide and carbon monoxide levels that had gone unchecked for a long time. Strict pollution regulations that arose in the early 1970s fueled the development of catalytic converters. The unrestrained power of muscle vehicles was put to an end in the 1970s as a result of these attempts to reduce air pollution. Around this period, government programs to minimize automobile pollution ushered in the end of muscle cars' unfettered might. The primary goal of this rule was to protect the catalytic converter, which was designed to remove dangerous compounds from exhaust such as carbon monoxide and nitrogen oxides before they entered the atmosphere. It was clear that designers were having problems incorporating this new technology into their previous models without incurring significant cost increases or functional losses. For instance, General Motors, one of the top automakers at the time, chose a rather straightforward and economical strategy. One large, pancake-shaped catalytic converter that they built was installed in the exhaust system. In this setup, a single catalytic converter received the exhaust from the engine's two banks, which was combined into a single pipe. With this technology, GM was able to surpass emission limitations without requiring more advanced engineering, but it wasn't without issues. Although it was successful in cutting pollutants, the pancake converter severely limited the flow of exhaust gases. Vehicles utilizing this technology compromised performance in order to comply with regulations, as evidenced by the significant drop in engine horsepower caused by the flow reduction. But Ford needed to go in a different direction. Instead of employing a single catalytic converter, as did GM, they installed two positioned nearer to the engine's exhaust headers. The exhaust fumes from the two sides of the V8 engine were treated independently before being emitted in this configuration, since each bank of cylinders had its own catalytic converter. Due to the converter's ability to heat up more quickly and start working sooner, especially at lower engine speeds, this approach, which is more in line with contemporary practices, allows for a more effective decrease in emissions. This tactic was not without its difficulties though. Due to the additional parts and complex engineering needed, the twin catalytic converter configuration was significantly more expensive than GM's single converter option. Although Ford's dual converter approach was clearly more successful in reducing emissions, it also brought attention to the challenging balance the auto industry was forced to maintain at the time. On the one hand, in order to stay in business and avoid paying large fines, they had to follow the new environmental standards. However, they also needed to make sure that they didn't turn off their clients by overcharging for the cars or providing a subpar product. Ford's determination to fully comply with emissions regulations was demonstrated by the dual converter strategy, even at the expense of increased production costs. The dual converter system worked well, but it wasn't installed on every Ford model. This leads us to the odd situation of the 1975 Ford Thunderbird and Lincoln Continental Mark IV. These specific vehicles came with a single catalytic converter in contrast to the dual converters seen in full-size Ford LTDs and Lincoln Town Cars. What's even more intriguing is that this single catalytic converter was only fastened to the bank of cylinders on the driver's side. An unexpected choice that was obviously made with cost savings in mind was the entire lack of treatment applied to the passenger side exhaust stream. Ford clearly deviated from their more thorough method found in other vehicles by choosing to treat the exhaust on certain models only partially. The cars met the pollution limits of the time despite only being able to clean up half of their exhaust output, so it was a cunning way to get around the restrictions. Ford was definitely able to save a significant amount of money on production expenses with this method, but it also raised concerns about the long-term impacts on engine performance and the actual efficiency of the emissions reduction. Pollutant levels significantly higher than those achievable with a dual converter system would have been released by the untreated exhaust from the passenger side bank. Although innovative in its cost-cutting strategy, Ford's choice to employ a single catalytic converter in the 1975 Thunderbird and Mark IV was beset by serious technical issues. Actually, the development of uneven back pressure between the two-cylinder banks was the most pressing problem. Higher back pressure was felt on the driver's side, which had the catalytic converter installed. This could cause the engine to operate unevenly. In order to maintain smooth functioning, engines are typically designed with balanced exhaust flows. Ford ran the danger of introducing operational inefficiencies into the engine by upsetting the balance, which might have decreased power and fuel efficiency. Without proper management, the mismatch that would have resulted in long-term wear and mechanical problems may have been caused by the passenger side's untreated exhaust flowing more freely. How the imbalanced exhaust system would have impacted engine performance as a whole was another possible issue. Inconsistent pressures and temperatures resulting from differing exhaust flows between the two banks may lead to problems like irregular engine component wear or unequal firing. Owner maintenance costs will go up and engine longevity will decrease as a result of these issues, which may not have been apparent at first. Due to the design, Ford also had to rely largely on the single catalytic converter's longevity, since any malfunction in this part may result in serious pollution violations and complicate the vehicle's long-term reliability even more. Due to new environmental rules, unleaded gasoline became the standard in the mid-1970s and was also required for the use of a catalytic converter. The catalytic converter may get poisoned by leaded gasoline, which would make it useless for cutting emissions. Many users who were still switching from leaded gasoline at the time found it difficult to comply with the requirement for unleaded fuel. If you noticed, Ford's approach put strain on the catalytic converter itself in addition to requiring this change. There was a greater chance of contamination and failure because there was only one converter to handle the emissions for a whole V8 engine. This may have resulted in higher maintenance costs and unsatisfied customers. Ford may have reasoned that, in theory, the effects of this asymmetrical exhaust system would be negligible, particularly in certain driving scenarios. It's possible that the exhaust flow was so low during regular daily driving and at low RPMs that the difference in power between the two banks was barely noticeable. The engine could have run more smoothly despite the unconventional layout if the H-pipe design had balanced pressures to some amount, which would have lessened some of the worst consequences. This logic implies that Ford's engineers were counting on the majority of drivers not pushing their cars to the point where these problems would surface, particularly considering the driving habits of the average owner of a luxury automobile in the 1970s. Still, this was a risky strategy even if Ford's anticipated benefits materialized. The long-term effects were less certain even though it might have worked in the short term. A modest rise in RPMs or more difficult driving circumstances could have revealed the design defects, resulting in performance problems and possibly expensive. Despite its cleverness, Ford's approach was ultimately a dangerous shortcut that put short-term cost savings and compliance ahead of the long-term performance and dependability of their cars. This technical analysis highlights both the creativity and potential drawbacks of Ford's approach by demonstrating how close the company came to going beyond what was technically possible in order to fulfill the new emissions criteria. When we look at the state of the car business today, the approach Ford took in 1975 would be deemed untenable. The tougher emissions regulations of today call for all-encompassing solutions that guarantee their all-exhaust gases are treated to reduce their negative effects on the environment. Technology has advanced to the point that such partial solutions are now out of date. Modern cars are made with complex systems that regulate every facet of exhaust management to ensure that they meet strict emissions regulations. The change is indicative of a larger industry trend toward more environmental responsibility, which is being fueled by growing public emphasis on sustainability and stiffer laws. Well, there you have it. What do you think about Ford's approach? Let's hear your thoughts. Also, don't forget to hit that subscribe and like button to keep you updated on our future uploads. Until then, I'll catch you on the next one.